I welcome you all for this lecture series. Today we are going to discuss some interesting topic on mechanical testing of materials. So this comes under engineering materials. Usually why we call materials as engineering materials? Yes, we do have answers for this. Materials are referred to as engineering materials because they are specifically selected and designed to meet the requirements and the demands of engineering applications. These materials possess certain properties and characteristics that makes them suitable for use in various engineering fields such as construction, manufacturing, electronics, and more. So engineering materials are chosen based on factors like strength, durability, conductivity, thermal properties, and other relevant attributes depending on the intended application. So the term engineering materials emphasize the deliberate and thoughtful selection of materials to ensure they meet the performance and safety standards required in the field of engineering. I hope you understood what is the real meaning of this engineering materials, and let us go into the testing part of the materials, where we find this tensile strength with the help of this equipment called universal testing machine. So again, why the term universal testing machine is being used? And it signifies its versatility in performing a wide range of mechanical tests on various materials. These machines are designed to conduct tests in multiple modes such as tension, compression, and bending, make them versatile and applicable to a broad spectrum of materials and testing requirements. The term reflects the machine's capability to universally access the mechanical properties of different materials under various conditions. So coming back to the equipment here, we have an upper crosshead, space for tensile specimen, movable crosshead, and a space for compressive specimen, load indicator, speed control, table. So why we call this universal testing machine? Because we can test all the maximum possible test in this material, right? So we have to prepare specimen according to American standards, and that standards we follow for a universal testing machine as E8, and according to that the specimen size is being determined. So after completing the specimen preparation, one has to mount this material in the universal testing machine according to the upper jaw and lower jaw in the next part of this. So this tensile test will have the following procedures like specimen preparation, as I have already told, and mounting the specimen, application of load, measurement of stress and strain, plotting the stress strain curve, and analysis of results. So after mounting the specimen in the upper jaw and lower jaw, gradual load is given to the specimen so that the specimen withstands maximum strength, and at one point of time when the level or the limit is reached, the particular specimen gets fractured. That point we call it as the failure point or the fracture point. That we can see by studying the graph which is available in the next slide. So normally an example of low carbon steel is being taken for stress strain curve. The strain is taken in the x-axis and the stress is taken in the y-axis. So we have different limits called proportional limit, yield point, ultimate tensile strength, and fracture point. When the material starts gradually loading, the stress is directly proportional to strain within the elastic limit, and that limit is nothing but proportional limit. And Hooke's found this particular phenomena so that it is named after Hooke's law. After that, beyond which the specimen starts yielding, where the point is denoted as yield point. And after that, the strain hardening happens in the fiber so that the material starts deforming slowly. So the necking point comes and the specimen gets fractured, and the point is called fracture point. So this is how the stress strain diagram can be inferred. So thank you for the patient listening of the lecture series. Thank you.